This method allowed the builders to utilize the water as a support system, providing stability and strength to the pylon. The cable-stayed bridge in Vladivostok is a remarkable engineering feat that is being constructed as part of the federal program for the development of Vladivostok as a center for international cooperation in the Asia-Pacific region. This bridge, which will connect Vladivostok mainland with Russky Island, is set to become a vital component of the transportation system in the Primorsky region. What makes this bridge truly unique are its extraordinary dimensions. With a height of 70 meters above the water level and a central span exceeding 1,100 meters in length, it is set to break world records. The pylon supporting the bridge will reach a height of 320 meters, and the state cables used will be an impressive 580 meters long. Construction of the bridge began in September 2008 and is scheduled for completion just before the Asia-Pacific Economic Cooperation APEC Summit to be held in Vladivostok in 2012. However, the builders have faced significant challenges due to the harsh weather conditions in the region. The wind speeds can reach up to 36 meters per second, generating waves up to 6 meters high, and the temperature can drop below -30 degrees Celsius in winter and rise to 37 degrees Celsius in summer. To ensure efficient construction operations, two production facilities were established, one on the Nazim Peninsula and the other on Russky Island. These facilities include workshops for rebar welding, building laboratories, and state-of-the-art concrete mixing plants supplied by Techwell, Boy and Compactors companies. Additionally, the facilities have mechanical woodworking and equipment repair workshops, office buildings, living quarters, and canteens. More than 1,300 meters of new railway tracks were built to facilitate the timely delivery of construction materials. The existing railway section, measuring over 4.5 kilometers in length, was also upgraded. To support the construction process, around 320 pieces of state-of-the-art special equipment were employed. This equipment includes unique 40-ton and 20-ton tower cranes capable of telescoping up to 340 meters for erecting the pylons. Russian-made derrick cranes with a lifting capacity of up to 400 tons were used for installing the channel span deck. Additionally, a crawler crane with a lifting capacity of 1,350 tons was installed to lift the first 10 sections of the steel span deck on Russky Island. Viaducts spanning a total length of over 900 meters were constructed to provide approach roads to the bridge. The viaduct piers are designed as columns, ranging from 9 to 30 meters in height. The spandrels of the viaducts consist of steel and reinforced concrete, with steel inclined wall box sections and a cast-in-place reinforced concrete slab. The heaviest and most complex structures are the bridge piers M1 on the Nazim Peninsula and M12 on Rusky Island, each reaching a height of above. These piers serve as load transfer points, supporting the horizontal load from the cable-stayed span stiffening girder. The builders used self-compacting B35-grade sulfate-resistant Portland cement concrete for the bridge piers and pylon foundations, providing protection against corrosive fluids and preventing rusting of the rebars. One of the notable aspects of the cable-stayed bridge construction in Vladivostok is the creation of man-made islets and peninsulas to establish the footings for the pylons. These innovative engineering solutions have played a crucial role in ensuring the stability and structural integrity of the bridge. On the Nazim Peninsula, a man-made islet was created specifically for pylon M6. This islet was formed by drilling boreholes into the ground and filling them with rocks. Borehole drilling is a technique that involves creating deep holes in the ground to reach stable bedrock or load-bearing soil layers. By using this method, engineers were able to establish a solid foundation for pylon M6, which is essential for supporting the weight and tension of the bridge. The pile footing for pylon M7 on Rusky Island took a different approach. Instead of drilling boreholes on land, a temporary steel islet was constructed in the water to serve as the foundation for the pylon. This required meticulous planning and precision to ensure the stability of the structure. Once the steel eyelet was in place, the pile footing was built from the water, creating a secure foundation for pylon M7. This method allowed the builders to utilize the water as a support system, providing stability and strength to the pylon. After the completion of the drilled piles and enclosing sheeting, another man-made peninsula was constructed. This additional peninsula serves as a protective barrier against various external forces, including impacts from vessels with up to 66,000 displacement tonnage, ice drift, and waves. The construction of this small peninsula involved extensive rock and dirt filling, creating a robust buffer zone between the bridge and potential threats. This protective measure ensures the safety and durability of the bridge in the face of challenging environmental conditions. In total, approximately 1.5 million cubic meters of rock and dirt were removed during the construction of the bridge, enabling the creation of these man-made structures. The drilling and pile concreting operations for these foundations were conducted from the water, a pioneering approach in bridge building in Russia. The water depths varied from 14 to 20 meters in different areas, presenting additional challenges that the construction team had to overcome. The use of innovative techniques, such as borehole drilling, temporary steel eyelets, and the construction of man-made peninsulas, demonstrates the ingenuity and expertise of the engineers and construction workers involved in the project. These solutions have not only provided solid foundations for the bridge pylons, but also contributed to the overall stability, durability, and safety of the cable-stayed bridge in Vladivostok. The completion of these remarkable engineering feats has attracted numerous visitors, government commissions, foreign delegations, and journalists throughout the construction process. Once the bridge is fully constructed, it will become one of the most important landmarks in Vladivostok, symbolizing the city's development and serving as a logo for both the country and the SK Maas group of companies.